Hello, I'm John Coleman from ApocatastasisInstitute for the Humanities and Alternative College and High School here on New Milford, Connecticut, USA. Today I'm being joined by Professor Adam Myers as we're going through Proposition 19 from Euclid's Elements in our series Euclid Today, looking at this, 2,300-year-old text, which has much to teach us because math doesn't change. Maybe mathematics instruction changes, and maybe that's interesting and necessary from time to time, but the principles never change. The elements never change, and there's a lot going on in the elements beyond once we get our propositions and our definitions under the belt, a lot more going on. And so I welcome Adam, and before I kick things over to him and turn on the screen share, um, one announcement concerning apokatastasis, and that is to check out our recent collaboration with Angela Malik and her music instruction. So Angela is very well acquainted with music, with chant, with classical music. She has quite a long singing career in music halls and so forth, both here in these United States as well as Europe. So she's a great treasure here at the Institute, and you can check out the flyer with Angela's information or contact information and the recording we did featuring what she offers in terms of instruction. So with that being said, Adam, welcome, and how you doing?
Hanging in there.
Good. Well, thank you for taking a few minutes out here to carry on our journey through Euclid
Mhm.
today as we normalize nudity, and that's something we'll be talking more about in our monthly show Adam and I do, and we get into philosophy and all sorts of nooks and crannies there. And um, without further ado, however, we're going to queue up Proposition 19. So let me just do that. And can you see that on the screen, sir?
I can, yes. Yes.
Great. All
Thankfully,
right.
this group is
So
going to be
you
really
have,
short.
okay, very good. I'm going to mute myself for audio reasons, and you have the floor, Adam.
All right. Well, like I mentioned earlier, this proof is incredibly short. It's basically just the converse of what we proved last week. You can scroll down, please. Yeah. So really all we're doing is we're reversing our setup. We're saying, okay, suppose that ABC, the angle ABC is greater than BCA. Okay, so BCA is shorter, or is a thinner angle. It's more acute than ABC. So we're assuming that. And what we're going to show is that AC has to be bigger than AB, which is the opposite of what we proved yesterday. Yesterday we proved that if AC is bigger than AB, then angle ABC has to be greater than BCA. All right. Now, the first part is a proof by contradiction. So we're going to suppose, on the other hand, that this weren't the true case. Let's suppose that AC was in fact either equal to or less than AB and see what happens. Well, if it was equal to, if you remember from proposition 5, that would show the two angles have to match. But they don't match. By assumption, one angle is bigger than the other. ABC is bigger than BCA by assumption. So we throw that out. That's not possible. Okay, the other alternative is that AC is smaller than AB. But that would mean that by the postulate that proposition we just proved last week, that would imply that ABC would have to be smaller than BCA. Right? That's what follows naturally from the previous proposition. Since that would contradict what we are assuming, we therefore conclude that that also isn't the case. And since the only two alternatives are thrown out, what we're left with is the conclusion that it must be greater. And that's the proof. Very simple and very elegant.
Great. Thank you for that, Adam. And again, if there's ever a delay, it's just because I'm turning on and off the toggles. on the screen there. Adam, before we knock off here and let you get on to Conan and your evening meal and whatever fun stuff you have ahead, what are some of the specialties you have in mathematics in terms of tutoring here at the Institute? If I was a parent or a college student, what could you offer? What do you offer, in fact?
Well, I would consider most high school math to be well within my purview because I've taught college algebra and we basically cover all of that same content. I've even tutored some sixth graders, or I've tutored high school students in sixth grade math. Long story on that. So I do have some experience in teaching children. I also have experience teaching at the college level. So I'm fairly confident in being able to cover any of the bases in high school math. That being said, for a college student, I am well acquainted with calculus, with probability and statistics. I've taken abstract algebra. I understand linear algebra. I've taken analysis. So if there's any proof classes that you have as an undergrad, I could probably help you out with that as a tutor, not as a teacher, but as a tutor. I've taught college algebra, so and all the and several of the remedial algebra classes. That's basic algebra and intermediate algebra. I've taught those as well. So if there's a course that you are needing help on, I probably can tutor it.
Great, thank you for that. Thank you. And as I pointed out last week, given Euclid's Elements here, a book originally composed in Greek, we are also offering, in addition to Latin and Arabic at the Institute, the Greek language. So there you go. There you go altogether. So
Awesome.
to the audience, thank you for your attention. And Adam, thanks for taking us one more step down the line with Euclid's Elements.
No problem. My pleasure.